topic of our today's video is circle theorem. The topic is from Mathematics 4024 syllabus, and the same learning objectives we have in IGCSE Mathematics 0580 syllabus also. So the learning objectives are calculate unknown angles and give simple explanation using the following geometrical properties. So we have properties here: angle in a semicircle, then angle between tangent and radius of a circle, then angle at the center of a circle is twice the angle at the circumference. Angles in the same segment are equal. Angles in opposite segments are supplementary. So first we will discuss what is circle. So the features of circle are: first, this is the circumference. Like the boundary of the circle is the circumference. The distance around the circle, its perimeter, because the definition of perimeter is sum of all boundaries. So as here we have only one round boundary, so if we take the length of this round boundary, it is perimeter or circumference of a circle. Next we have diameter. Diameter is the distance across the circle passing through the center of the circle. So if a line touches the circumference at 2 points, okay, and it is passing through the center of a circle, then we will call it diameter. Next we have radius. The distance from the center of the circle to any point on the circumference is called the radius. Like if this is the center of the circle, okay, so if we take the length from the center till the circumference of a circle, so all these are radius of the circle. Now this is chord. Chord means if again a line touches 2 points on the circumference of a circle, but it will not pass through the center of the circle, then we will call it chord. A line joining 2 points on the circumference. Then in chord we have two segments. The first one, which is the smaller one, like this one is the smaller one, so this is minor segment, and the big one is the major segment. So this is major segment, and this upper one is the minor segment. Then we have arc. So if you check this arc, see this green line which is on the circumference of a circle, this is an arc. So part of the circumference of a circle is an arc. Now this is tangent. Tangent means a line which touches the circumference at one point only is tangent. Like if we draw a line on the circle and it will touch at one point of a circle, so it means it is a tangent. Now the properties of circle. When angles, triangles and quadrilateral are constructed in a circle, the angles have certain properties. So the first property is an angle on a chord. So it means that if we have a chord, like this is one of the chord, okay, so if we draw some segments, like we have drawn one segment like this on this chord, and similarly we have drawn one more segment on this chord, okay, so it means that these two angles are equal. So remember, an angle on a chord are equal. So if we have this angle here, okay, this is not the part of this chord because it is on the opposite side. So if they are starting and ending like this, so these two angles are same. Similarly, for example, we have another chord joined with this, okay, another segment. So if this is a chord, so here we have drawn three segments on this. So all these angles are equal, okay. So if the starting and the ending point of these segments are the starting and the ending point of the chord, so all these angles are equal. So angles subtended by a chord in the same segment are equal, okay. So this is, we have segment, and then these all angles are equal. So angle in the same segment are equal. This is one of the property of a circle, that angle in the same segment are equal. Now next we have, see here we have one of the examples. So if we have to find A and B, so imagine that this is a chord. Okay, this is one of the chords. So see that the starting and the ending point are same. So we can say that angle B is equal to 28 because these two are segments, okay, with this chord. Similarly, if we draw a chord here, imagine this is a chord, so it means that these two are segments. So these two angles are also equal. So A is equal to 44. Now here we have another one. So see that if you draw these lines, because in the previous one this line was not drawn, when we check the actual question, see this line was not drawn here. So if we draw these lines, so it will help us to find the angles. So very often the exam tries to confuse you by drawing in the chords. So when you draw these lines, it will be helpful for you. So you have to see the angles on the same chord for yourself. Then here we have the next property. So the first property was that the same segment has same angles. Now here the second property is, consider two angles which stand on this same segment, okay, same chord. Again here we have a chord, okay, and these two are angles. One angle is here and the other angle is here. So what do you notice about the angle at the circumference? So if this is the angle at the center, this 88 is on the center, and we have to find this angle at the circumference. So if we have a chord and we have these two segments like this, okay, and they are facing each other, then in this case we will say that angle at the circumference, okay, is half at the angle at center. So in other words we can say that angle at the center is twice angle at the circumference. So if we multiply 44 by 2, we will get the angle at the center. Or similarly, if we divide 88 by 2, we will get angle at the circumference. So angle at the center is twice angle at the circumference. It is half the angle at the center. So the property is, if two angles stand on the same chord, then the angle at the center is twice the angle at the circumference. Now here we have one more example of this. So it's not necessary that the angle must be above this angle, okay, like if one angle is here, so if the angle is above this, then only in this condition it will be half of the angle at the center. If we have angle like this, for example, okay, here again this is the chord and these two are segments 1 and 2, okay, so this angle is also half of this, okay. So either we have point A here like this, or either we have point A here. In both conditions this angle is 44, half of angle at the center, okay. So the property is angle at the center is twice angle at the circumference, okay. Now one more condition, like for example we are having this angle, okay, this angle is 136. Now to find the angle at the center, this angle, if we take the half of 136, okay, or if we multiply 136 by 2, we will not get 88. So it means that if we change the apex, then the angle will also change, the angle will be here. So if we multiply 136 by 2, we will get this angle 272, okay. So this is very important that the faces of the angles should be same. Like if we have a segment here like this, then this angle will be half of this angle at the center. So these two are having same faces, and similarly when we talk about this 136 angle, so this 136 and this angle are having same faces, okay. So remember this. Okay, then the next property is, so right now we have this, till now we have discussed two properties. The first one is same segments, and the second one was that angle at the center is twice angle at the circumference. So if we follow the same property here also, so we know that this diameter is a straight line. Okay, so if we draw the straight line, so when the angle stand on the diameter, what is the size of the angle A? So if this angle is 180 degree, okay, so angle at the circumference will be half of 180, so it means this angle will be 90 degree. Okay, so the diameter is a straight line, so the angle at the center is 180 degree, and then angle A will be 90 degree. Okay, so this is 180 and this angle is 90 degree. See, now it means that here if you have a semicircle, so semicircle will make 90 degree angle. So this is the third property, that the angle in a semicircle is a right angle. So we have discussed till now three properties. The first one was same segment, then we have discussed angle at the center is twice angle at the circumference, and now we have discussed that semicircle will make 90 degree angle, or we can say that any point on the circumference of a circle will make 90 degree angle with the diameter. So for example, if we have this point here, so if we draw this with the center, this angle is also 90 degree. Similarly, for example, we have one point here. If we join this with the diameter, this angle is also 90 degree. Okay, so all such cases are 90 degrees. So any point on the circumference of a circle will make 90 degree angle with the diameter of a circle. Now the fourth property is cyclic quadrilateral. Cyclic quadrilateral means if we have a quadrilateral inside the circle whose all four vertices are on the circumference of a circle, then we will call it cyclic quadrilateral. Again, I am repeating that if we have a quadrilateral inside the circle and all four vertices of a quadrilateral are on the circumference of a circle, then we will call it cyclic quadrilateral. The property is opposite angle in a cyclic quadrilateral add up to 180 degrees. So it means the sum of the opposite angles in a cyclic quadrilateral is equal to 180 degrees. So they are supplementary. Either we have a quadrilateral like this, so the opposite angles will be equal to 180 degrees. So 60 plus 120 is equal to 180 degree. Similarly here, as we have a quadrilateral, so this is one of the vertex, 1, 2, 3 and 4. So these two are opposite. Okay, and similarly these two are opposite. So the opposite will make a sum of 180 degrees. So 140 plus 40 will be equal to 180 degrees. Then we have one more example here. Similarly, here we can have the semicircle property also. Like this is the diameter of a circle, okay, and then these two angles will be 90 degree, and if we add these two angles, it will be equal to 180 degree. So opposite angles in a cyclic quadrilateral add up to 180 degree. So sum of the opposite angles in a cyclic quadrilateral is equal to 180 degree. Similarly, the sum of these two angles will also equal to 180 degree. Okay, so in a cyclic quadrilateral, the sum of the opposite angles equal to 180 degree. So for example, we have this question, and in this question we have a cyclic quadrilateral, and so if this angle is 63, so how we can find this alpha angle? What we will do, we will minus 63 from 180 degree to find the value of alpha. So if we subtract 63 from 180, it is 117. So angle alpha is equal to 117. Now if we find angle beta, then how much it will be? As we know that this is the diameter of a circle, this line is the diameter of a circle. So here we have a semicircle property. Okay, so this angle is 90 degree. So if we take this triangle, this one, Okay, so 90 plus 63 and we will subtract it from 180 degree. 90 plus 63 is 153 and if we subtract it from 180 degree it is 27. So angle beta is equal to 27. Okay, so angle alpha is equal to 117 and angle beta is equal to 27. And the reason of these angles are, for alpha the reason is cyclic quadrilateral and for beta the reason is sum of the three angles of a triangle equal to 180 degree. Now here we have another question, and if you look at this question, here we have angle at the center is twice angle at the circumference, and we have same segment also. Like if we draw this chord, okay, angle M is at the center and 49 is on the circumference. So if we multiply 49 by 2, 98, so angle M is equal to 98. Okay, and the reason is angle at the center is twice angle at the circumference. Then angle N will be equal to 49 because here we are having same segments like this. Okay, so angle N will be equal to 49 and the reason is same segment. So when we in some of the questions they will ask you to write the reason, okay, otherwise they will just ask you that what is the angle, so you will just find the angle and write in the answer space. Otherwise if they are asking to write the reason also, then you have to write reason as well. Now here we have another example. So here also angle at the center is twice angle at the circumference. So if we multiply 49 by 2 we will get angle K, which is 98. But here when we find angle J, J is not half of 98, this is not 49. So what we will do, first we will subtract 98 from 360 degree to find this angle. So 360 minus 98 is equal to 262. So it means this angle is 262. Now when we divide 262 by 2, it is 131. So angle J will be equal to 131. Okay, so as I have told you that the faces of the angles should be same. So if 49 is having face towards this side, K is also having same face. Okay, similarly if J face is on this side, then this angle is also have face at this side. Okay, so the first we will find this angle, the remaining angle, and then we will take half of this, so we will get angle J. And if we write the properties of this, for both cases the property is angle at the center is twice angle at the circumference. Now here we have another example. So in this one we are not having an angle at the center, so we cannot take half of this, so we will get angle S. So what we will do here, we can see that this is center of the circle, so these two are radius. If these two are radius, so it means that it is an isosceles triangle. So if it is an isosceles triangle, then if this angle is 46, this angle is also 46. If we subtract these two angles from 180 degree, then this angle is 88. So angle at the center is twice angle at the circumference. So if we divide 88 by 2, angle S will be equal to 44. So the reason is angle at the center is twice angle at the circumference. So what we have done, first we got this angle at the center through when we subtract these two angles from 180 degree. And why this angle is 46? Because these two are radius. So when these two are radius and these two sides are equal, so it means it is an isosceles triangle, and in an isosceles triangle the base angles are equal. So these two base angles are equal. So when we subtract 46 and 46 from 180 degree, our answer is 88. So the third angle of this triangle is 88. So we have got angle at the center, and when we take half of this we will get angle at the circumference. Now we will discuss the properties of tangent. So when a tangent to a circle is drawn, the angles inside and outside the circle also have properties. So we have few more properties also. Right now, till now we have discussed 4 properties. The first one was same segment. The second one was angle at the center is twice angle at the circumference. Then we have discussed semicircle property. Then we have discussed cyclic quadrilateral. Now the next property is tangent and radius. So remember that a tangent is perpendicular to the radius of a circle. So when we draw a tangent on the circle, it will always make 90-degree angle with the radius of a circle. This is the radius of the circle. So it will always make 90-degree with the radius of the circle. Or if you have even diameter, so this tangent will make 90-degree angle with the diameter of the circle also. So tangent will always make 90-degree with the radius of the circle. Then we have another property. So if we draw a tangent on the circle, if we draw two tangents on the circle from one outside point. So here the outside point is P. So if we draw two tangents on the circle from this outside point, then the length of these two tangents will be same. Tangents are equal. PA is equal to PB. These two tangents have same length. Then if we draw a line from this outside point till the center of the circle, like PO bisect angle APB. So when we draw this line, it will bisect this angle into two equal parts. These two angles are equal. Okay, angle G and angle G. These two angles are equal. Then we have learned in the last property, we have learned that when we draw a tangent on the circle, it will make 90-degree with the radius of the circle. So OA and OB are the radius of the circle. So it will make 90-degree angle with the radius of the circle. Okay. So these two are the radius. So these two angles are 90-degree. When we draw this blue line, it will bisect this angle into two equal parts, angle G and angle G. And similarly, these two angles are also equal. So through this line, we will bisect this angle at the center also. Now, after this, we can say that these two triangles are congruent. Triangle OAP and OBP. These two triangles are congruent. OAP and similarly OBP. These two triangles are congruent. One side is common, one side is radius. The length of the tangents are also equal. Angles are also equal. So all angles and all sides are equal in this condition. So here we can say that these two triangles are congruent. Now if we apply these properties on one of the questions, so here we have a question. In the diagram, points A, B, C and D lie on the circle center O. TA and TB are tangents touching the circle at A and B respectively. So TA and TB, these two are tangents. So as we know that tangent has equal length also. If we draw these tangents from one outside point, then AOB angle is 132 and ACD angle is 59 and AOC is a straight line. Okay. AOC is a straight line and it is diameter of a circle also. Find angle ATB. ATB means we have to find this angle. Now as we know that the radius will always make 90-degree with the tangent of the circle, so these two angles are 90-degree. Similarly, if we draw a line from this outside point till the center of the circle, it will bisect this angle into two equal parts. So, and this angle will also bisect into two equal parts. So, if we divide 132 by 2, it's 66. So, it means these two angles are 66 degree. So, if we consider OAT triangle OAT, then two angles we have. If we subtract these two angles from 180 degree, then we will get the third angle of a triangle. So this is 24. And if we multiply 24 by 2, then we will get this complete angle ATB. So we will multiply 24 by 2. So this is equal to 48. Okay. One more thing we can do, like if we take the quadrilateral OATB, the sum of the four angles of a quadrilateral is equal to 360 degree. So if we add 90, 90, 132 and subtract it from 360 degree, then also we will get complete angle T. Okay, so it's up to you. You can perform any property here to find this angle T. Then the next angle is angle BDA. Angle BDA means we have to find this angle. So when we find this angle BDA, we know that this is at the circumference and we have the circle at angle at the center. Angle at the center is 132. If we draw this chord, like if we join AB, this is a chord. Okay, so these two angles will be, angle at the center is twice angle at the circumference. So it means that if we divide 132 by 2, we will get angle at the circumference. So this angle is 66. Now the third angle is BDC. So to find this angle BDC, this is angle BDC. Now if we apply a property here, so we know that AOC is the diameter of a circle. This is the diameter AOC. So it means that this is 90 degree. Any point on the circumference will make 90 degree angle with the diameter of the circle. So if we join these two lines, this angle is 90 degree. So as we know that this angle is 66, so if we subtract 66 from 90, we will get angle BDC. So if we subtract 66 from 90, this is 24. So this angle is equal to 24. Okay, and this angle we have got BDC by divide 132 by 2. So we have got this angle 66. So the first angle we have got by tangent property. The second angle we have got by angle at the center is twice angle at the circumference, and the third property we have got through the semicircle property. Okay, so if we quickly recall all the properties, the first property was same segment. The second property was angle at the center is twice angle at the circumference. The third property was semicircle. So any point on the circumference will make 90 degree angle with the diameter of a circle. Then we have discussed cyclic quadrilateral. In cyclic quadrilateral, if we have a quadrilateral inside the circle and all four vertices of a quadrilateral are on the circumference of a circle, then we will call it cyclic quadrilateral. And the property is the sum of the opposite angles equal to 180 degree. Then we have discussed all these four properties, and we came on to tangents. In tangents, we have discussed that if we draw a tangent on the circle, then it will always make 90 degree with the radius of the circle. And then the last property we have discussed, that if we draw a tangent from one outside point, the length of the tangents will be same, radius will be same, and the radius will make 90 degree angle with the tangents. So the angles will be 90 degree, and if we draw a line from the outside point till the center of the circle, then it will bisect our angle into two equal halves. Okay, so these are all the properties. I hope all the properties are clear and you can easily apply these properties on the questions now. Thank you.